part, to do a particular work, time is involved. You are given a particular job, it could be anything. You might be sent to draw water from well or do whatever. Now, for you to have started that job, you moved from point A to point B. Before you executed the job, you finished executing the job, maybe you spent 1 hour. At that junction, what you have applied is power. Because power is the rate of doing work. Now let's go to the mathematical expression. Mathematical expression of power. Mathematical expression of what? Power. What do you say power is? Power is the rate of doing work. So it means that power is what? Work over what? Time. Work done is in joule, while your what? Time is in what? Seconds. But the SI unit of power is now what? Given in what? Watts. Is given in watts. That is W. Capital W. So that is the SI unit of what? Your power. Remember, power is what? Work done per unit time. For you to calculate power, you have to calculate your power with respect to what? Time. So for every work you actually do with respect to time, is not what? Joule. I mean, it's not energy, but what? Power. Now, under power, there are things we need to what? Take note. Under power, there are some little phenomena we must what? Know. Number one, there is what we call horsepower. Let me put it here. Note number one, there is what we call horsepower. HP. What is horsepower? What's horsepower? Horsepower is just a phenomenon that has been coined out by scientists to actually what? Make people differentiate layman. When you say a layman language from what? A scientist language. What do I mean? One horsepower is always gives what? 760 watts. 760 watts approximately. Or this is the actual figure, 746 watts. So you can say 1 horsepower. If you want to make it the whole number, that's 750 watts, whichever one you are using. So that is the what? Description of what? Power in terms of what? Horsepower. Which means that if you have a particular engine, you might decide to go and buy an engine. It might be a rotatory engine. When I say a rotatory engine that what? That rotates at its what? About its axis. I say a rotatory engine. An engine that rotates. This is the axis of that engine. When it rotates this way, it's a rotatory engine. If you buy a rotatory engine and you are being told that that engine has 700 horsepower, at this junction, you'll be able to know what is meant by horsepower. You know that they are talking about the rate of power at which that engine will have. So if you will calculate the horsepower of this engine to what? To what? You should be able to calculate it, because you know that 1 horsepower meant 746 watts. That's point 1. Point 2. Note 2 that we need to put in mind. This is the first note, note 1, and this is our note 2. Under our note 2, you must know what we call kilowatts. What is 1 kilowatt? What is 1 kilowatt hour? 1 kilowatt hour. 1 kilowatt hour is what? 1 kilowatt hour is what? 1000 watts. 1000 watts times 3600 seconds. What do you mean by this? 1 kilo. Let's break it down. 1 kilo. In science, you should be able to know what they call kilo. 1 kilo, then watts. Anywhere you see kilo means what? 1000. Watt is the SI unit of what? Power. Hour. 1 hour in your what? Time. When you say 24 hours, make 1 minute like that. So 1 hour will always give you what? 60 seconds times 60. You understand? 60 times 60 seconds, which will give you 3600 seconds. So at this junction, the 1 hour is a 3600. The kW is your 1000 watts. So if you must convert 1 kilowatt, you are converting it by saying 1000 times or 3600 seconds. So that is what we call That is what we call 1 kilowatt. So if you are to break it down completely, you have 3.6 times 10 raised to power 6 joules. Because there is nothing like watt seconds. At the time you combine these two, you have your joule. So 1 kilowatt hour is the same thing as what? 3.6 times 10 raised to power 6 joules. So that is breaking down the 2 points I'm emphasizing on. Number 1, horsepower, and number 2, kilowatt hour. How do you convert kilowatt hour to what? Horsepower. Okay, let's go to exercises under our work, energy, and power. Exercises under what? Work, energy, and power. Exercises under work, energy, and power. Number 1, look at this question. A body of mass, they gave you the mass of the body, 20 kg. Falls through a height, falls from rest through a height of what? 20 meters. Follow the question. In science, you have to learn how to write out your parameters. You don't just read the question through and then you manufacture the formula and solve. No, you must write out your parameters of which you are using to what? Solve your question. Now, falls through a height, 20 meters, and comes to rest, having penetrated a distance. So this will be your H2. This is your H1. That's the height at which is falling. Having penetrated a distance of 0.5 meters into a sandy ground. Good. Calculate the average force exerted by the sand in bringing the body to rest, giving your acceleration due to gravity to be what? 10 meters per second. Yeah, you have to really need to analyze this particular question. It's very technical. You draw some diagram to explain it. Now, this body falls. So he fell from this height, and while falling, he covered this particular distance. That is, that's your first H, which is your what? 20 meters. Now, this is the ground surface. Now, when it now got to this ground, due to the force at which it's using to come down, it still penetrated another what? Distance into the soil. That's what they're actually trying to say there. And that gives us the second what? Height. And that second distance it penetrated through the soil is 0.5 meters. What do? You are told here to calculate the average force exerted by the sand in bringing the body to a stop. Now, what do you do here? The first thing you need to do is to calculate. You now say, for me to get my average force, force is given as what? Your work done. Let's first look at the work done. Work done is what? M times G times height. You must get your work done first. The work that is done by bringing that, by the body to be performed, as in the work that is performed by the body, from falling from this height to this height. What do we do? Work done is given as, your mass is what? 20. Your gravity is 10. While your height, the height at which is fell, is 20. So from there, your work done is what? 4,000 joules. We have established work done as what? 4,000 joules. So the work done here is what you now use to what? This is your first occurrence. You see, in science, you have to learn how to analyze questions. The more you can analyze your question, the more you get your full mark. If eventually you are writing your SSC physics, for instance, the more you analyze the question to your what? Examiner, the more the mark you get. Because each of your analysis will give you some extra marks. So you have to learn to do what? Analytic. So your first occurrence, this will be your first occurrence. This will be your second occurrence. Now, from the first occurrence, I could get my work done as what? 4,000 joules. Now, I will now go to my second occurrence, which is work done times what? Mass times what? Mass times gravity times height. Now, the height exhibited here is 0.5. So I'll just say 4,000 joules will equals my mass, which is 20. Okay. If you look at the question, let's go back to the question. They said average force. So here now, what do? Mg as what? As represented a force. So you have to recall. You tell them recall that your force is what? Mass times what? Acceleration due to gravity. And acceleration due to gravity is this G here. So from there, you have a force here. Now, you now input your force into your formula. So from there, you have your 4,000 equals your what? Force times that height. And that's your I2. So from there, you have your 4,000 equals force, which is what you are looking for, times the small height, which is 0.5. So from there, you'll be able to obtain your what? Force as what? 4,000 divided by 0.5, which will give you 4,000 over 5 times 10. If you divide it, you have 2. So your force here, your average force here is what? 8,000 Newton, which is what? 8 kilonewton. That is the average force that is being exhibited by the body to penetrate the ground at this particular distance. So that's for question 1. Question 2, you go through it. Question 2 says a body of mass 60 kg runs up a set of steps at height 3 meters. What is the work done? This one is very straightforward. Since it's at a height, so what is that one giving to telling you? It's telling you that it's a work done on what? On force field. So if it's work done on force field, this is number 2, that's question 2. We are looking at what? Our work done equaling to mass times gravity times what? Height. Mass from that question is 60. Acceleration due to gravity is 10. While your what? While the height